Hello all, welcome to JustQuant. In this video, we'll solve some problems based on absolute value. To start with, how do we calculate the value of x in equations involving modulus or absolute value functions like absolute value of f of x plus g of x equal to k? So when we have equations involving modulus functions, we can proceed by first making the equation independent of the modulus sign. How do we make an equation independent of the modulus sign? Let's first have a look at the definition of the absolute value function. Here, we see that absolute value of x is equal to x when x is greater than or equal to 0, and when x is less than 0, absolute value of x is equal to negative of the negative number x, thus making it positive. Similarly, our absolute value of x minus a is equal to x minus a when x is greater than or equal to a. When x is less than a, x minus a is negative, and hence absolute value of x minus a is minus of the negative number x minus a. In general, absolute value of f of x is equal to f of x when f of x is greater than or equal to 0, and when f of x is less than 0, it is minus f of x. So here we see that in order to remove the modulus sign, we try to identify those values of x when f of x changes its sign, and based on which we categorize our approach to the solution into cases. Here, our case 1 will be f of x greater than or equal to 0. When f of x is greater than or equal to 0, our absolute value of f of x is f of x. So we write our equation as f of x plus g of x equal to k. And when f of x is less than 0, our equation modulus of f of x plus g of x equal to k becomes minus f of x plus g of x equal to k, as the modulus of f of x is equal to minus f of x when f of x is less than 0. Right? So now we have these equations independent of the modulus or the absolute value sign. Hence, we can solve these equations for x. Okay? Let's now solve an equation for x. Absolute value of x minus 3 plus 2x equal to 7. We have absolute value of x minus 3 is equal to x minus 3 when x is greater than or equal to 3, and when x is less than 3, x minus 3 becomes negative, and hence absolute value of x minus 3 is minus of x minus 3. So our case 1 will be x greater than or equal to 3. When x is greater than or equal to 3, absolute value of x minus 3 becomes x minus 3, and hence our equation is x minus 3 plus 2x equal to 7. Solving, we get x equal to 10 by 3. This satisfies our case that x must be greater than or equal to 3, and hence x equal to 10 by 3 is a valid solution. Now in case 2, we have x is less than 3. In this case, our equation becomes minus of x minus 3 plus 2x equal to 7. Solving, we get x equal to 4. But x is equal to 4 does not satisfy our case that x must be less than 3, and hence this is not a valid solution. So the value of x For the equation absolute value of x minus 3 plus 2x equal to 7 is x equal to 10 by 3. Let's now solve another equation involving an absolute value function, absolute value of x square minus 7x plus 12 equal to x square minus 9. Here, x square minus 7x plus 12 upon factorization gives us x minus 3 into x minus 4. So these factors will help us in identifying those values of x for which x square minus 7x plus 12 changes its sign. That is, when x is less than or equal to 3 or greater than or equal to 4, x square minus 7x plus 12 remains positive, and when x is between 3 and 4, x square minus 7x plus 12 becomes negative. Hence, our first case is when x is less than or equal to 3 or greater than or equal to 4. In this case, our equation becomes x square minus 7x plus 12 equal to x square minus 9. So solving for x, we get x equal to 3, right? In the next case, when x is between 3 and 4, the equation becomes minus of x square minus 7x plus 12 equal to x square minus 9. Now solving for x, we get x equal to 1 by 2 or x equal to 3. But this value of x is not satisfying a case that x must be between 3 and 4. Hence, this is not a valid solution. But in case 1, x is equal to 3 satisfies our case that x is less than or equal to 3 or x is greater than or equal to 4. Hence, x is a valid solution of this equation, right? So the solution or the value of x for the equation absolute value of x square minus 7x plus 12 equal to x square minus 9 is x equal to 3, right? Let's now solve for x comma y given that absolute value of x plus 3y equal to 5 and absolute value of y equal to 4. This gives us x plus 3y equal to plus or minus 5 and y equal to plus or minus 4. So based on the value of these two equations, we have the following cases. Case 1 is when x plus 3y equal to 5 and y equal to 4, we get x equal to minus 7 and y equal to 4. And case 2 is when x plus 3y equal to 5 and y equal to minus 4, we get x equal to 17. And case 3 is when x plus 3y equal to 5 minus 5 and y equal to 4, we get x equal to minus 17 and y equal to 4. And case 4 is when x plus 3y equal to minus 5 and y equal to minus 4, we get x equal to 7 and y equal to minus 4. Okay, thus we have the values of x and y in each of these cases. So we'll end this video here. I hope it's clear. Thanks for watching.